Literal equations are just equations that have multiple variables in them. So generally when you're dealing with formulas and you have a lot of variables, you use all the same solving methods as normal equations. You're just going to have extra variables in your answer. Your goal is still just to isolate a variable. So in this case, we are trying to isolate r. Now whenever a variable is in the denominator, we're eventually either going to have to multiply by that variable or do some type of cross multiplying to get rid of it. We could multiply both sides by r right now, but I want to keep with your normal method of rational equations. So generally whenever you're trying to solve something with fractions, in this case we want to first get all the fractions together. So that means on the right side we want to combine those two fractions. Well, in order to combine those two fractions, we need to get a common denominator, which in this case would be r1, r2, and then we can add them. So the first fraction needs r2, multiply top and bottom by r2. The second fraction needs r1, so multiply the top and the bottom by r1. So this gives us r2 plus r1 on top, r2 times r1 on the bottom. We got our common denominator, and then we just added them together. Now, when we get to this point, you can either think of this as cross multiplying, the easier way, or you can think you have to clear your denominator. So, we go cross multiply. This means we have 1 times r2, r1, so it just stays as is. If you have that order switched, that's fine. Multiplication is commutative. And then on this other side, we have r times r2, r1, plus r1. So now you could distribute that in, but here's where you always want to think of your end goal. Whenever you're solving problems, don't forget what your end goal is. That end goal is to solve for r. If we distribute that in, we're making more r's. That makes our life harder. In this case, to solve for r, we have r times all of r2 plus r1. We just need to divide that out. So divide both sides by r2 plus r1. Cancels out on the right side, and we are left with r equals r2, r1, again, or r1, r2, over r2 plus r1. And that's it. So now the thing with literal equations is they're all a little different because it's all just different equation solving methods. So we'll go ahead and go through 119 as well. Okay, for this one, we have s equals a over 1 minus r. We're solving for r. So again, whenever the variable you want is in the denominator, we need to get it out of the denominator. So in this case, there isn't any other simplifying we need to do. So to get that out of the denominator, we just need to multiply both sides by the entire denominator. And remember, that denominator should be in parentheses because we're multiplying by that whole piece. So when we do that, on the right side, the 1 minus r's just cancel out. That's the whole point. You multiply in order to get it out of that part of the problem. And then on the right side, we have 1 minus r times s, and we have equals a. So at this point, we need to solve for r. Right now, r is being trapped in parentheses, which means we need to get it out of the parentheses. To get rid of those parentheses, we just need to distribute that s. So now we have s minus s times r, or r times s, again, order doesn't matter, equals a. Again, think about the end game. We're trying to solve for r. I know it looks confusing to have extra variables in there, but just pretend like they're numbers. Think about what you would do. If you were, for example, trying to solve a problem, complete sidetrack, say it was 2x plus 4 equals 5. You're trying to solve for x. That you guys could do in your sleep. You know your first step, subtract the 4 over, and then you divide by the 2. Same deal over here. Get rid of the addition subtraction first. Subtract your s to the other side. Subtract because it was positive. So now we have negative sr equals a minus s. And we're trying to solve for r. So right now that says negative s times r. So to get rid of the s, we just need to divide. So divide out our negative s. Those go ahead and cancel, and we're left with r equals a minus s over negative s. Those s's cannot cancel. Do not make that mistake. There is addition and subtraction happening on top. There is no cancellation we can do there. We can simplify it though. Notice there's a negative in the bottom, so essentially you're dividing by a negative, which means if you want to make this look a little nicer, if you divide a positive a by a negative, it would be a negative a. It would turn into a positive s. Now we just have a normal s on the bottom. You can make that look even easier if you wanted to, and just make it s minus a over s. Any of those three on the bottom would be a correct answer to that problem.